okay, that is greater than 1 and has no factors other than 1 and itself. What is the smallest prime number that we can have? 2. Okay, I already prepared my ice cream stick so that you want to eat. Okay, so Joshua, can you give me another prime number as an example? Sorry, who's Joshua? Yeah, right, yes. Give me another prime number. Any prime number? 3, okay, so our prime numbers that we know, we have 2, we have 3, okay, let's just call another person. Give me another one. Lucas yes. Another prime number. 5, okay, so, alright, so we have all these prime numbers that we know. Is 1 a prime number? Let's see. Trixie. No, okay, 1 is not a prime number. What else is not a prime number? Emmanuel? Who's Emmanuel? 4 is not a prime number. Okay, that's great. Okay, what else is not a prime number? 18. Yes. 0, great. Okay, so not a prime number. We have 4, 1, 0 just now. Okay, so even numbers tend not to be prime number other than 2. Okay, not all odd numbers are prime as well. We also have 9, for example, that's not prime. Okay, so those are clarified already. Because these are all very small numbers. What if I actually want to find out, okay, a very big number? For example, okay, give me a 4-digit number. Let's start with giving me 1 digit first. Kaylin, can you give me 1 digit? Where's Kaylin? Kaylin? Yes. Sorry? 5, okay? 5. Give me another digit. Xavier. 9, okay? 1 more digit. Kira. Give me 1 digit. 0 to 9. Huh? Oh, Kyra, sorry. I need to get used to this, yes. Sorry? 8, okay? Now, give me something that ends off as odd number, okay? Because we know even numbers surely are not prime number. Okay, so Elise. 7, okay. So we want to know whether 5987 is it a prime number or not. It's not going to be an easy task, isn't it? Okay? Because for these numbers, okay, we can memorize it, right? We know whether they have factors, what kind of factors they have. But 5987, how do we go about finding it out? Okay? So there is a program, okay, that I have on this exercise over here. You can try out at home, okay, on your own. But let us just give it a try for simple numbers first, okay? So let's say if I start off with something small like 7, okay, I will key in the number 7. Let me just clean up the whiteboard, right? So I key in the number 7 and it says to continue to press enter, okay, to test. So they divide it by 2. They see that there is a remainder, okay, of 1. So 2 is not a factor. Okay. Then they continue, divide by 3. 3 is not a factor. Okay. Then 4 is not a factor. They just continue down the list. Okay. And finally, when it reaches 7, okay, since all the numbers from 2 to 6 they are not factors, they conclude that 7 must be a prime already. Okay. So why is it that they don't even bother dividing by 1? Because when you take a number divided by 1, surely that it is going to be a factor already, right? Okay. So if I want to retry it, okay, so let's try it now with our very big number over here. Okay, 5987. How is it going to work out? Okay. First we divide by 2, divide by 3. It's going to take a long time. Let's see. How long do you think it will take before realizing what is the first factor? Very long? Let's see. So is it a prime number? It seems like it's going to be a prime number, right? Because it's like going on forever. Okay? But if I really go and press it all the way, just investing. Right? Now I'm only at what? Dividing by 135 is going to take me forever. I'm not going to try that out. Okay? So is there a limit or is there a simple way to actually continue? See? Okay, now I press until it hang already. So I think this software probably has given up as well. Okay? So we find that when it comes to very large numbers, if I try this out, start dividing by 2, okay, all the way to 5986. Okay, this is going to take forever. Alright? As mathematicians, we always want to find out short methods, short ways, efficient methods, alright, to actually solve a problem. Correct? Because we don't want to find long methods. We don't want to bother to go to the moon and come back. Okay, when we just want to go to Serangoon, we just take bus 147 and reach Serangoon already. Okay, don't need to go to the moon before taking the bus to go Serangoon. Right? So that's the whole point about learning mathematics. We want something efficient. Okay, so this is clearly not an efficient process. Okay, I'm going to skip those questions there. You can try it out on your own. So what we see over here is that for any number that we have, if a number n, we use a letter to represent that unknown number. If it is going to be a prime number, we notice that we have to divide from 2 all the way to, in this case, 5986. To check whether is any of the numbers here going to be a factor or not going to be efficient. And that will mean that actually if I go and count, there is n minus 2 devices. So if the number is of size n, I must test from number 2 all the way to n minus 2. Sorry, n minus 1, right? And there are n minus 2 of them. Don't need to bother yourself with all the algebra now. But essentially, there is a certain number over here. In fact, there are a total of 5985 numbers to test, alright, to see whether is it going to be a prime number or not, and not going to be efficient. So what I'm going to introduce to you now is a more efficient method. There's this thing called child division method. So if none of the devices from 2 all the way to square root n, so instead of testing up to 5986 in this case, I just have to test until square root of 5986. In order to check whether is this going to be a prime number or not. Alright? So maybe 5987 is definitely a very large number to go and test. Let's do something simple first. Let's cut it short, 87. So we just have to test in the child division method. So let me get my numbers ready. First, let me just read out what I've just written down. In the child division method, for the number 87, we take the number 87 to divide the numbers from 2 to square root 87 to check if any of those values are factors or not. If there is a factor between 2 to square root 87, then 87 is not going to be a prime number. Because one number can only have 2 factors, and 87 itself. Correct? If there is an additional factor that is between 2 to square root 87, then it means that 87 must be not a prime number. Okay? If there is no factor, then we know that the factors will only be 1 and 87, therefore 87 is prime. Okay, I just give you a minute to copy this down before I explain why this actually works. Okay, those without a notebook, I expect you to copy it down on foolscap paper. Later on, you transfer it. Okay. Are we done? When you're done, please put your pen down so that I know. Are the 2 points there you finish copying already? Where are you copying it in? Look at everybody around you. Where do they copy their things in? Okay, everybody is copying their notebook. You copy that. Okay, whatever you copy is going to be important because you are revised from this notebook itself. You don't expect me to give you notes, okay, to actually do revision for you. Alright, I'm not going to take 1 week to summarize the entire year for you. You have already summarized it in your notebook. Okay? Alright, are we ready to listen? Okay, why this method works? No? Okay, later I'll give you time to actually continue copying. I want you to listen and pay attention now. Okay, and then also you need to start increasing your speed of writing. Okay? So now we start. I give you this example, 30. 30, we clearly know that it is not a prime number, right? Okay? So why is it that the trial division method actually works? Because let's say 30, right? We know that the factors are going to be numbers such as 2 times 15, 3 times 10, 5 times 6. We of course will also have our 1 times 30 lah. Okay? Why is it that we consider up to the square root only? Square root 30 is about how much? Can you press your calculator and tell me square root 30 around how much? 5.477. There about, right? Okay. So what we see is that, right? Okay, in every pair of factor, one of it, okay, one side of it is going to be lesser than the square root. Okay, do you see that the numbers over here, 1, 2, 3, 5, they're all lesser than 5.477. And on the other side, it will be more than. Okay, now is it possible to have factors such that both of it are lesser than 5.477? For example, okay, if both numbers, one is 4, then the other one is something else, okay, maybe like 3 or something like that. Okay, if both of it are lesser than 5.477, surely when they multiply, they are not going to hit 30 at all. Agree? Okay, whatever number that you put in these blanks, if as long as they are smaller than 5.477, okay, if you're multiplying them, they surely will never hit 30. Okay, now if both of it are larger, then what will happen? Okay, if they are larger, let's say one of it is 6, the other one is 7. 6 times 7 we know is 42. Okay, it will surely exceed 30 itself. Okay, so the thing about square root 30 is that, okay, when we see that number, we can identify, okay, half of the factors already. There are 8 factors over here, I can identify this part. If I can find out the numbers over here, do I really need to go and find out the rest of the numbers? I don't need, right? Because once I know this, I just take 30, let's say divide by 5, I can find the other side. Okay, so that's why in the 12 division method, all I needed to do is that in the number 87, okay, imagine what if they have a lot of factors. I just need to find out half of it, okay, which are all going to be lesser than square root 87. Okay, then I will be able to know if none of it, okay, if I cannot find a factor, then 87 is going to be a prime number. Okay, if I cannot find a number over here to fill out the space. Okay, but if I can find a number, a factor, then 87 is not going to be a prime number anymore. Okay, so that is the idea behind our 12 division method. Okay, you are not going to be expected to go and explain this out in words. Okay, but I want all of us to have the understanding. Okay, if you didn't catch what I said, don't need to worry. Okay, when you go back onto a SLS, okay, you can go and try to type out an answer over here. When you submit your answer, there is a feedback. I have actually put in a video that you can go and watch to understand the whole process. Otherwise, you can go and re-watch today's video also to go and understand what I was trying to say. Okay, this is really more for your knowledge. Right? So we will now use this method, okay, to actually solve a question. Okay, I'm not going to solve whether 87 is prime or not. That one, I will leave it to you to do as your own practice. But now I want us to turn to our textbook, practice now 1, textbook page 6. Okay, so my SLS, I will also link it with the things that you have in your textbook. We're now looking at this question. Are we there? Page 6. So in your notebook, okay, how are you going to take notes? Right? You're going to just write down, practice now 6, question 1. If you want to write textbook page number, also can. Don't need to copy the question, that will waste a lot of time because you already have the question in your notebook. Okay? So you just write your header of some sort or in the column. Practice now 6, question 1. Okay, I don't like you to actually write your answers in your textbook because it will get very crowded, very difficult to read and to revise later on. So write all your answers, okay, in your notebook. My own habit, okay, for your knowledge is that I write questions in black. Okay, my answers are usually written in blue. Okay, of course up to you to decide. I'm just telling you so that you know what you need to copy. Okay. So this question thing you need to write down so that you know what am I answering. So now, first, the question asks, are 534 and 1607 prime or composite? Okay, so let's check 534 first. In our 12 division method, I will have to test from 2 to square root of it. So let's go and find out what is square root of 534. Could you press your calculator and tell me at around what is square root of 534? 20? Okay, 0.108 there about, right? Okay, so what we have to do is to take 534, okay, you can just press your calculator. The first number that we will divide is divided by 2, right? Can it be divided by 2? Obviously, right? Okay, and that will be equals to 267. Okay, so since it can be divided by 2, that means there is a factor. Can it be a prime number? No. So therefore, we conclude that 534 is composite since it is divisible by 2. Okay? So that's how we solve the first part of the question for 534. Any questions so far? Okay. Next, we look at 1607. Okay. Sorry, just a show of hands. Does anyone not know how to press the square root function in the calculator? I hope we know. Okay. So do give it a try. Even if your friend shout out an answer already, please press your calculator to give it a try. If you don't know, never mind. Don't need to be shy. Okay. So for 1607, we do the same thing. Find out square root 1607. What is it going to be? What do we have? 40.087. Okay, about this number. So we will go and test, okay, all the division of 1607 from 2 all the way to about 40, okay? So we will divide 1607 by 2 till about 40. Okay, so what you need to do is that you just go and press your calculator. Okay, just press your calculator, no working required. Can you go and try 1607 divide by 2? What do you get? Okay, so in order to be a factor, the answer that you get upon division should actually be a whole number. Okay. So 1607 cannot be divided by 2. Try divided by 3, cannot. Okay. Done? Is it a prime number? How many of you say it's a prime number? Who says it is not a prime number? Who is still trying it out? Okay, just press. So that's why we need to learn how to increase our speed in pressing. Okay, do we have it? It is a? It's a prime number because we cannot find any factors, right? Okay, so therefore, it's a prime number since there are no factors other than 1 and itself. Okay? Now, is there even better and more efficient method? We notice that in this question, right, I take 1607 divide by 2 all the way to 40 can also be very tedious. Right or not? Yes, okay? So actually, what we can improve in terms of this trial division method, okay, is to divide the number by prime numbers. Okay? That will be even better. But this is provided that you are familiar with all the prime numbers, all the smaller prime numbers. Okay? So I can divide 1607 by all the prime numbers from 2 to 40. Okay? That means that I just have to divide by 2. So the possible numbers will be 2, 3, 5, 7, 9 cannot be, 11 13 sorry, 11 is a prime number. 13, 17, 19, 20, 21, 22, 23, 24, 25, 26, 27 cannot. 29, 31. Let me just write it up. 31, 35, 6, 7. Yeah. Okay, so this would possibly be all the prime numbers that you just need to divide by. Okay, why? Because, for example, if this number can divide by maybe 14, if 1607 can divide by 14, then surely can divide by 7, right? Alright, 7 is a prime number. Okay, if 160 can divide by 26, it can also be divided by 13. Agree? Okay, so that's why dividing by the prime numbers will actually be enough already. Don't need to go through all the numbers. Okay? Questions? Alright, so we'll end here for today. Okay, tomorrow we'll continue with the remaining questions. Alright? Please make sure that tomorrow you bring all your stuff. And tomorrow we expect to actually be on our